Welcome to week 8 notes. This week we're going to learn how to multiply polynomials, monomials times polynomials. First, we're going to distribute the term through the parentheses, simplify, then write the answer in standard form. Let's start with some simple examples first. I'll give you a second to write these down. But if you would please copy 2x squared times 4x cubed. What we're going to do is multiply the coefficients, that's the 2 and the 4, that becomes 8. So 2 times 4 is 8. Then x times x cubed. Whenever we have a variable with an exponent and we multiply it by the same variable with an exponent, we add the exponents. So that means x squared times x cubed is x to the 5th power, 2 plus 3. Let's try another one. 2r squared t times 5t to the 3rd power. We'll multiply the coefficients. 2 times 5 again, we'll get 10. R squared, we can't multiply times another r, so we're just going to leave it as is. And then the t is multiplied by the t cubed, and there's a 1 here. So we're going to add 1 plus 3. And we're done. Last one, 3x times the quantity 2x squared plus x plus 4. First thing, multiply the coefficients. But we have to multiply these terms on the outside by each term on the inside. So 3x times 2x squared. Again, don't forget there's a 1 there. 3 times 2 is 6. X times x squared is x to the 3rd. Now we can multiply 3x times x. Draw these arrows. 3 stays the same because there's a 1 there. Then x times x, there's a 1 there. That's x squared. 1 plus 1 is 2. Finally, we have 3x times 4. 3 times 4 is 12. And then our x stays there. And we're done with that one. Let's just do a few more to make sure you understand. Our next problem is 4 times 4x squared plus x plus 3. Our first step is going to be drawing our arrows. The 4 on the outside gets multiplied by each term in the inside, and the terms are separated by pluses or minuses, as you can see. 4 times 4 is 16. The x squared stays there. 4 times x, well, there's a 1 out here in front, and there's also a 1 up here. So it's 1x to the power of 1. It's the same thing. We just don't write the 1s. 4 times 1 is 4. And then we have our x there. 4 times 3 is 12. And we're done. Let's try a few more. 3ab, that means 3 times a times b, times the quantity 5a squared plus b. This is going to be interesting. 3 times 5, I don't want to get ahead of myself, Okay. After I draw my arrows, 3 times 5 is 15. A, that's a 1, and this is also a 1 over here, right? A to the first times a to the second, we add the exponents. 1 plus 2 is 3, a to the third. B stays there. Now we have to multiply the 3ab times the b. 3a stays there. This sign comes down. And then b to the first times b to the first is b to the second power. And we're done with that one. Let's just do one more. 5r squared s squared times r minus 3s. Now, we have this term on the outside, and it looks like a pretty big fat term, but it still is one term, and we're going to multiply it by everything, or I should say each term, within the parentheses. So 5r squared s squared times r, well, the 5 stays there, there's a 1 here, and there's also a 1 there. So 5 times 1 is 5. R squared times r to the first is r cubed, and then s squared stays there. This term here times negative 3s. 5 times negative 3 is negative 15. R squared stays there, nothing to add to the power. S squared times s to the first is s to the third power. Now question, can we combine this together? And the answer is no, because it's not exactly the same. Why? Because the variables are not exactly the same. We have an r to the third here and an r to the second here. We have an s to the second here and an s to the third here. It has to be exactly the same for us to be able to add or subtract these coefficients.